So last class we just looked into the assembly program, correct? So assembly program, what is assembly program? It is So we just worked on something called assembly level program, ALP. Okay, so it has some kind of short words, and using that kind of short words, we define instructions. Okay, so each instructions has some pattern, general format, opcode, and operand. Okay, operand, and you have n number of operand. Now, if I can show you the instruction. Okay, say for example, if you type 8051, no, 8051 instruction set. So if you type like this, so now you can see these are all many instruction what 8051 asks. You can see here. So these are the different types of instructions. You see, data transfer instruction, arithmetic instruction, logical instruction, okay, Boolean instruction, and branching instruction. Okay, these are the different instructions, and under that you can see lot of instructions are there. Okay, so many instructions are there. Arithmetic, many instructions are there. Logical, many instructions are there. Boolean, many instructions are there. Okay, branch control instructions are there. Now we last day we just understood this only one instruction, that is MOSI. You see. So that's the only thing we understood. Last class we just worked on move instruction. If you remember, only one instruction we worked. That is move instruction. Likewise, to understand this microcontroller or to work on the programming part, so we should know all this instruction. Okay, so one should know all this instruction, what this instruction does. So using this instruction only, we have to build any program, any kind of logic we have to implement using these instructions. Okay, so very easy to understand all these instructions. Okay, so now so one by one we have to understand. So data transfer instructions, arithmetic instructions. So we have to understand. So in all the microcontroller and microprocessor, it is like that only. Say for example, ARM7 instruction set. Okay, so if you open ARM7 instruction set, so there will be list. Okay, so there will be a list of instructions. So now not here. So you will get the list of instructions. You just have to use that particular instruction to write a program. You see. Okay, so all kind of move, arithmetic instructions, logical instructions, everything you have in ARM also. Okay, so that is common thing. So that is how you have to search. Now what I'm doing, 8051 instruction set, I'll learn. Okay, so basically I had to learn all these instructions. Now what we are trying to learn this part. Okay, let us learn these two things together. Okay, in the initial phase. Okay, what is that? Data transfer instructions and arithmetic instructions. We shall start, exploring. You see, so data transfer instructions and arithmetic instructions. So we will explore and we'll work on that, and slowly we will extend our instructions to the next level. Okay, so that is the idea. So now what we learned now, see for example, if you see here, these are all, you can see a lot of instructions are there. Move C, move X, push, pop. Okay, X, CH, XC, HD. You see, different instructions are there under data transfer instruction. Okay, now let us understand what these instructions in 8051. Okay, so that is, let us understand that particular part, and let us work on that program. Say, so what we are in ALP. So what we are trying to learn, data transfer. Okay. Data transfer instruction. We are working on data transfer instruction. So we know few things about move instruction. Okay, So move instruction, okay, what happens in move instruction? So move instructions transfers data. Okay, so transfers data. So what is that move instruction does? Move instruction, basically if you have a microcontroller 8051, okay, so this is 8051. We know that internally we have a memory. So memory is varies from 00 to FF. Okay, so many registers are there. Okay, many registers are there. So this and also you have special function registers, okay, which is the part of this particular data memory, internal data memory. You see, you have an internal data memory. So what is this move instruction? If you want to move data, okay, inside this particular data memory within this internal memory, so then this move instructions is useful. Now if you see the instructions last day what we have done, so move a comma say hash 10h, that means what we are trying to do, we are trying to move the constant 10 value to accumulator. What happens, that 10 is moving inside this e0 is the location of a register, right? E0. So E0 is the address of accumulator. So what you are moving, 10 is moved to accumulator. So internally, inside microcontroller, you are doing that work. Say we have executed one more task like a comma b. That means the content of b will move to accumulator. The content of b will move to accumulator. So content of b will move to accumulator. You see. So what is happening here also? Internally data is moving. Okay, inside microcontroller data is moving. So the data transfer is happening. In that case, you have to use this particular instruction called move instruction. So if you see, all the instructions, say for example, 10h. Okay, move a comma 10h. What is 10h? The 10h address content. The content present in 10 the address will move to accumulator. You see. Okay, so the content present in the 10th memory will move to accumulator. So that is what is happening internally. So the data is moving inside a microcontroller. Okay, so in that case you have to use this instruction called move. Okay, move instruction. Okay, the second one what we have to learn is about very important instruction called move x. Okay, move x instruction. Move x instruction. Okay, this is for the external memory access. Okay, so external memory access. You see, external memory access. So this is your 8051, and what happens? You see, to point yeah, here you see move x. So the memory, internal memory you have, but external memory if you interface. Okay, now you know what is the how much maximum memory you can interface, 2 to the power of 16. So that means 16 address line. Okay, you can use. So 16 address line you can connect. Okay, and 8-bit data line you can connect to the external memory. So external memory is also sequence of register which varies from 000 to FFF. This much memory you can connect. Okay, so totally 64 kilobytes. Totally 64 kilobytes of the external memory you can interface. Okay, so now using move x instruction, you can transfer data. So that means move x is for data memory. So move x is for the data memory, external data memory, external data memory. Remember, if you want to work on external data memory, that means external RAM. You see, external RAM. External data memory means external RAM. Internal memory you have 00 to FF. Okay, so if you want to work on the external memory, then you have to use this MOVX instruction. Remember, the data, the data size is the 8-bit only. You see, the data size is 8-bit only. Okay, so address is basically 16-bit for the external and 8-bit is for the internal memory. Okay, so in 8051, okay, so remember this particular part. Okay, so now this is what now you attach some external memory. Now you see why external memory is required, because any program you need to attach external memory to keep your program as well as to keep your data. Okay, so to do all those things you have to interface external memory. Okay, so this one you should know. So what is this memory? This memory is external RAM. Okay, external RAM or external data memory. Okay, remember this. So now, what we do? So we have using this instruction, we move data from internal memory to external memory. Okay, from internal memory to external memory. Now, what is that? Here, basically what we are trying to do here. So last class we understood, okay, if you remember, we understood program counter. Okay, so we understood program counter. So program counter, this is the address pointer. Okay, so this is address pointer. Okay, so this is address pointer. It holds the address of current executing instruction. Okay, it holds the address of the current instruction. You see, okay. Similarly, we understood one more, what is that pointer? That is DPTR. Okay, which is called data pointer. Okay, so data pointer. So this DPTR is also internal register. Okay, so DPTR. Remember, DPTR is also internal register, 16-bit register. Okay, DPTR is the internal register. Okay, internal 16-bit register, which is used as a data pointer. Okay, so data pointer. What is data pointer? It is basically, see, you have a lot of data in external memory. Now, so now how can I know which memory I am pointing? Okay, so you have 64 kilobytes of memory location. So among all the things, which memory location you are pointing? Okay, to know that, so what we have to do? So we have to load this DPTR. Okay, so we have to load this particular DPTR with that particular address. Say, if you are loading this particular, so this is internal memory. Okay, so if you load this particular DPTR like 8000 in internal memory, okay, so that means you are pointing to that 8000 memory location. Okay, so if you save 8000 in this particular DPTR in internal space, that means you are pointing to the 8000 memory location external. So now you are pointing to external memory, which is 8000 memory location. By changing this particular value, this DPTR value, you can point to different data in the external memory. Okay, you can point to the different memory in the external memory. So data pointer you have to use whenever you are working on the data. Okay, so you are clear about this particular point. So this is the DPTR is basically data pointer. Okay, so data pointer. Okay, this is 16-bit register. Okay, 16-bit register in a internal memory. Okay, and this is external memory data pointer. Okay, this is useful for only external memory. So that is what you have to understand. So hope you understood this particular instruction called MOVX. See, normally, most of the work, why I'm explaining this particular instruction, because you see, whenever you are loading your operating system, okay, whenever the loading of your operating system, now what happens? The data will move from your hard drive to RAM. You see, data transfer will happen. So MOVX will come into picture there. Okay, MOVX will come into picture because you are dealing with external memory. Okay, so assume that you are copying data from pen drive to pen drive. What is happening? External memory. That is external memory. Normally, your laptop has a microprocessor which do not have any internal memory. Okay, you are interfacing external memory. So every time MOVX is what happens. Whatever you execute, MOVX is the command which is executed in the microprocessor or microcontroller. So MOVX is called in 8051 or different ways, different mnemonic. Okay, they will provide for in different microprocessor. So I'll come to that. Now hope you are clear on this particular aspect. Okay, so now coming to the programming part. Okay, so now I'll just demonstrate, and I'll try to validate using this particular instruction. So now this program is open. Now you see, last class we worked on this. So let me create a new program. So now what is that? External, memory interfacing, okay, access or something like that. Okay, it may be your external memory means, it can be your, RAM, hard disk, pen drive, okay, whatnot, okay, whatever you are connecting. Now what we are trying to understand, this instruction called MOVX. Okay, MOVX a comma, okay, this is always this instruction a comma at dptr. Okay, so remember this. Okay, so this is the syntax what you have to use. Move a comma at dptr. Okay, so where is dptr present in this? So dptr is present here. Okay, so data pointer is present here. So that is external memory data pointer. Okay, whatever. Now what is, where it is pointing? It is pointing to 0000th memory, external memory. Okay, we also included external memory when we are creating this particular project. That means external interfacing is there. External memory interfacing is there. So now, okay, move a comma at dptr. What is the meaning of at symbol? At symbol means the data present in this particular register will act as an address. Remember, you understood? Remember this. Okay, so at dptr means, say 8000 if I keep, that will act as an address. Okay, and the data present in that particular address will be taken. Okay, now what is that? You can see here. Say I am loading 8000. So if this will be act as an address, and then it will go to that particular address, and the data present in that particular address is basically at dptr. Okay, so that means now it is there is some data is there. Okay, say 33. Okay, I kept 33. Then that 33 will come to accumulator if you use this instruction MOVX. Hope I am clear. So this the data present in that particular address will act like a address, and the data present in that particular external memory will be fetched. So that is what this instruction does. MOVX. Okay, to the external memory access, you have only you have these two instructions only. MOVX a comma at dptr. Okay, at dptr comma a. So these are the two instructions what you have in with respect to MOVX. Okay, either you can move from the external memory to accumulator, or you can move accumulator to external memory. So bidirectional data flow, you can understand. Now what I'm trying to do, I'm trying to move data from the memory to A is what? A is internal memory, correct? Internal register. So I'm trying to move the data present in external memory to the internal memory. Okay, so that is what I'm trying to do here. So now you see which memory. Okay, so dptr is pointing to 00. Now I want to specifically point to some memory. So now you see move dptr comma, okay, hash, okay, 8000h. Okay, 8000h. What this instruction does? Now you see move I am using. Move if you are using, that means that is internal data transfer. Okay, internal data transfer. So DPTR is a one register in 8051. So in that particular register, I am keeping 8000. That's all. Some hard coded value I am putting it in DPTR register. Now that DPTR content is always data pointer. Okay, so now when I run this particular program, the data present in 8000 memory location, external memory location, will come to accumulator. Okay, so hope you understood this particular logic. Okay, so now where is that external memory? Where can I see that particular external memory? So external memory here, if you create a project, there is one thing called X data. Okay, so you can click on this particular X data. You can see the external, RAM. So this is your external RAM. Okay, so now you can go to any memory by by changing the address here. Now I am just moving 8000. Okay, now 8000. Now here you see 8000 is 00. Okay, what data you have? 00 is the data. Now you can change that one. Okay, you can change the data by your keyboard. Okay, so now what you have to understand now, you see, uh, I kept some data in RAM. Okay, so now what statement you can do here? In 8000 memory location, 11 is there. 11 is the content. In 22 is present in 8001th memory location. Okay, 8001th memory location, you can see. In 8002th memory location, 54 content is there. Okay, so that is how you can access the RAM. Okay, so this is how you can see the external memory. Okay, so now what I'm trying to do now in this particular case, what should be your understanding? So this 11, I want to take to accumulator. That means, so the 11 is present in external memory. This is the external memory. Okay, so this is basically the external memory. So this 11, I want to bring this particular value to microcontroller. So then what you have to use? You have to use these two lines. Okay, so let us carefully observe this one and see how this works. Now I'll run this program. I'll go to simulator mode. Okay, I'll just give some program name. Let's just given some name. Okay, so I executed and it compiled successfully. It compiled successfully. There is no problem. Okay, so now what is that? What you have to do now? I am running this program. I am just clicking on step run. Okay, now can you see here? After running first instruction, you can observe here. Okay, the data pointer is changed now. Okay, now the thing is, now the your microcontroller is pointing to 8000th memory location. Okay, now it is directly connected to that particular memory only now. Okay, so now what you can do now what happens, you see. Now you know what is the data present in 8000 memory location 11. Now you see what is the content present in this accumulator 00. Now when I run this particular instruction, let's see what happens. Can you see here now? The hexadecimal 11 value came to accumulator. That means what you have done, you have taken the data from external memory to internal memory. You see, external memory to internal memory you have taken. Okay, so remember, program counter is different from the data pointer. That differentiation you should know. Program counter always keeps the address. Okay, and DPTR always points to the what is that? A data memory. Okay, this one you have to be very careful. Now you understood this particular part. Okay, now this is one way, taking data from external memory to internal memory. Assume that you have done some calculation or something like that, and you want to move content to the external memory. Move, say, copy the data from the internal memory to external memory. Okay, in that particular case, like say for example, I want to, yeah. Any questions, Rupal? Not audible. Rumbab, you're not audible. Okay, I think unknowingly pressed unmute button. So now what is this? this instruction will copy data from external memory to internal memory. Now what I'll do, so I'll take up one more DPTR. So I'll go to some other memory location, say 900H memory location. Now you see move at DPTR, okay, comma A. Now what it should do? Okay, now what this program does? Move X. Okay, so move X. External memory na move X. So that's why when I type move, there was error. Okay, so now this what this instruction does, let us see. So you see 8000 memory location 11 is there. Okay, let us go to 9000 memory location. So you can see in 9000 memory location 00 is there. Okay, so in 8011 is there. Now let us run this particular program again. Okay, so now this RAM is there, and let us see in 8000 memory location 11 is there. Now when I run this program, you see the data pointer will become 8000, and the data present in the particular address will be copied to accumulator. Okay, it came 11 came to accumulator. Then you see the DPTR is now 8000. When I execute this instruction now, it should become 9000. Okay, now you see the data pointer become 9000. Now here what happens, you see, now here memory, let us go to this memory location 9000. In 9000 00 is there. Okay, so now say let me keep this particular this particular screen. Can I keep the screen on top? And there's no provision. Yeah, so now when I run this particular instruction, let's see what happens. I ran this particular program. Now can you see here what reflection you are getting? So that 11 came to external memory. So it's from internal memory you are moving to external memory. Okay, so this is how you can do internal and external memory data data transfer. Okay, so because we will be using this particular things, most of the operations we will be using this movex command. That's why you just have to be very sure about this particular instruction. Okay, so any questions on this? Any questions on this? Any questions or any clarification required? Please do ask in chat box. Okay. In Keel also similar, in Keel also. So what you can do, you can open. Okay, so simultaneously both the things you have to learn side by side. What is this? Where I type this program. So that program is okay. Came here and I'll just try to build. Okay, so then what I'll do, I'll go to debug mode. Okay, so yeah, so now here you can see DPTR. Okay, so DPTR present here 8000. I'll just run so 8000 so data memory. I just have to to go to the data memory, you just have to type X. Okay, 8000 in the in this particular keel. Now I'm just giving say same 11 only. So let me take that particular value. Okay, see in accumulator 11 came. Okay, 11 came, and then you see the DPTR. So DPTR 8000 now. So now when I run again, it become 9000. So let me move to 9000 memory location. So 9000 is there. When I execute this particular instruction, it become 11. You see, so that bidirectional data flow is possible now. We understood how it can be done. Okay, so in Keel as well as in MCU 8051, we executed. Now even directly you can burn this particular program to microcontroller. This does that particular data transfer work. Okay, so very simple. Okay, so any questions? If you have any questions, you can ask or you can take a leave, and we'll continue in the next class.